In this session, we will see how Quarkus supports the deployment of Quarkus applications as serverless services on OpenShift. Quarkus simplifies the deployment of applications as serverless services on OpenShift with a very neat extension called the quarkus-openshift extension. The traditional source-to-image workflow generates the deployable artifacts of the applications inside OpenShift. However, the quarkus-openshift extension uses the S2I binary workflow to provide a more streamlined deployment process. So instead of building from the source, the extension uses either the jar files or the native executables from the local file system. As a result of this, the build process is up to 10 times faster than the traditional S2I methods. So this extension can be used when deploying the applications either from a local machine or from a build server or even the continuous integration systems to perform repeatable builds and deployments. Since this extension uses the S2I binary workflow, this extension will push the serverless application image into the OpenShift's internal image registry. So if you would like to leverage an external enterprise image registry like Quay, for example, then still the extension can help you up to the point where it can create the native image, and then you can push the image to an external image registry of your choice and then use the Knative CLI to create the Knative service for your serverless application. All right, now let's see the Quarkus OpenShift extension in action. Now, before we do that, let's take a quick look at the set of properties that are to be set in the Quarkus application to enable the Quarkus OpenShift extension to create the Knative service. So the first property is the Quarkus Kubernetes deployment target, which has to be set to Knative, and setting this property enables the creation of deployment descriptors for the Knative service. Then the next one is the Quarkus OpenShift build strategy, which tells what is the build configuration strategy to be used in OpenShift to build the application image. It has to be set to the value called Docker. Then we have the Quarkus Kubernetes client trust certs, which is set as true in this case to indicate whether or not the client should trust a self-signed certificate that's presented by the API server. And I've been using an untrusted certificate, and that's why I have set this property value as true here. Then, to direct the OpenShift serverless to pull your container image from the OpenShift's internal image registry, we need to specify this Quarkus container image registry with a value of the path or the URL to the internal image registry of the OpenShift cluster. Then, by default, Quarkus assumes the project name from which the container image should be pulled to be the same as the username of the host system from where the deployment is triggered. So to specify the right project in which the image stream will be available, we need to set this property Quarkus container image group to the point to the right project name where the container image stream is going to be available. Then to get the serverless application compiled into a native executable, we need to configure two more properties. The first one being the Quarkus native container build, which is set to true to enable the container runtime, and then the Quarkus native container runtime, which has to be set to the values of either Docker or Podman to really indicate the container engine that it has to use internally. Now, you may be wondering about the need to have graalvm set up to really generate the native executable. However, it's really not required because the extension that we have will use the Red Hat provided base image for Mandrel, and Mandrel is a downstream release of graalvm that's focused on the native image creation for Quarkus applications. So the Quarkus OpenShift extension will automatically pull this Mandrel image from the Red Hat registry and use it for the native executable creation. Finally, the property Quarkus OpenShift native Docker file helps to specify the custom Docker file that is to be used to build the container image, which will ultimately host the native executable that we would be creating. Now, with all of these properties set, triggering a Maven clean package with -p native and -d quarkus Kubernetes deploy equals true will result in the creation of native executable and ultimately the deployment of the application as a serverless service into the OpenShift cluster. So with that, let's take a quick look at the Quarkus OpenShift extension in action. Now, to start with, here is a simple Quarkus application that provides REST services for the creation and maintenance of order data. And this order data has a one-to-many relationship with order line item data. And also this application uses a MySQL database as the backend store. Now let's start with enabling the Quarkus OpenShift extension in this project by adding this dependency to the form.xml of this particular project. And now after enabling this extension, the next step would be to add all the relevant properties that we discussed just now to the application.properties file of this particular project. And then we have this Docker file that's going to help in the creation of the container image for our application using the native executable. Now, this Docker file uses the Red Hat provided UBI as the base image, and it copies the generated native executable to it, and it also sets the relevant permissions for the non-root user, and finally, the command to launch the native executable. Now, with all of these set, let's go ahead and trigger the deployment of this application. So when we execute this command, maven clean package -p native and -d quarkus Kubernetes deploy equals true, what is going to happen behind the scenes is this extension will start creating the native executable first using the Red Hat provider mandrel image. And as you can see here, in these steps, specifically the native image build step, we can see that it has already started to pull the Red Hat provided mandrel image, and this will be used for building the native image. And this process will take some time, so let's give it a few minutes for this one. All right, now that the Maven command execution is complete, let's take a quick look at the logs to see what has happened. Now, going up, we can see that in the native image build step, the native executable was created, and after the creation of the native executable, the corresponding image streams, the build config, and all of that has got created behind the scenes in the OpenShift project. And finally, using the native executable, a specific container image has got created using the Docker file that we provided, and ultimately the image has got pushed to the specific internal image registry of OpenShift for that particular project. And finally, the application was also deployed as a serverless service in the OpenShift project. Now, let's take a quick look and see if the Knative service has got really created. So let's list down the services in this project, and we can see that the Knative service for this application has already got created. So now that we can see this Knative service, this application specifically relies on some of the properties from a config map in order to connect to an underlying MySQL database. So let's update the Knative service definition that's generated by the Quarkus OpenShift extension to use the config map that contains the database connection details. So let's do that by using the Knative service update command to specify the environment variables that are to be used from this config map. So let's do that. And now that the Knative service configuration is updated to use the environment variables from the config map, let's go to the developer perspective of the OpenShift web console and see if the serverless application is running. And we can see that it is indeed running. So let's open it up and invoke one of the REST APIs to see if the serverless application works or not. And we can see that the serverless application is now working as intended. Now, as I mentioned earlier, if you would like to use an external image registry for storing your container images, now what we could do is we could really use the same extension first to create the native executable. So if you could see this command, we just don't have the command that triggers the deployment, but we have the command up to the point where it generates the native executable. And then you can use your tool of choice, either Podman or Docker, to really build the container image and then push it to your relevant choice of external image registry. And then finally, once again, you can use the Knative CLI to create the Knative service for your applications. So let's take a quick look at how this could be done. So once again, let's go back to the application. And for this purposes, to demonstrate this particular aspect, let's use a different project. So let me change the project to Quarkus serverless external image registry. And we have this project ready. Now in this project, let's go ahead and deploy our application. Since we have already created the native image, we will not be running the relevant commands to generate the native executable once again. So given that we have the native executable already available, let's just go ahead and build the container image, which is going to use this native executable. And once again, we will be using the same Docker file that we had seen sometime back. So we will be using the same Docker file, and let's trigger a Podman build. And this will start the build. And as we can see, the Podman build has started to happen. Let's give it a few seconds. And yeah, so we have the Podman build complete. Now let's once again go ahead and push the image, the container image that we had created just now, to the respective external image registry, which is going to be Quay in this case. So let me push this image to Quay, and this will take another few minutes. So let's give it a few minutes for this. All right, now that the image has got pushed to the Quay, now let's go ahead and create the serverless service for this application and do the deployment. So let me do the kn service create, and let's just execute this command and give it a few seconds. And once this command execution will be complete, we can see that the serverless service for this application would have got generated using the image that we had pushed to Quay. Okay, with that, the application is already deployed, as we can see from the message here. And if we go back to the developer console, we can see that the Knative application will be up and running. So this is in a different namespace, which would be Quarkus serverless external image registry. And as we can see that the application is already up. And if we go in there and trigger the same API once again, but this time from the application that has been created using the image that we had pushed to the external image registry, we can see that the application is working as expected. Now, with that, we have come to the end of this session. I hope this session was informative, and thanks for watching.